Limit is y goes to 2 of y minus 2 divided by the tangent of y squared minus 4. The first thing we're going to do is try plugging a 2 in for the y's. That will give us 2 minus 2 divided by the tangent of 2 squared minus 4. So we have 2 minus 2 over the tangent of 4 minus 4. 2 minus 2 is 0. 4 minus 4 is 0. So 0 over the tangent of 0. So 0 divided by the tangent of 0 is the sine of 0, 0, divided by the cosine of 0, 1. 0 over 1 is 0. So we have the 0 over 0 indeterminate form. We will need to rework this. Since this is due to trig functions together with power functions, we're going to make use of the identity. Limit as theta goes to 0. It looks like we're probably going to end up with a sine in the denominator, so I'm going to write the theta over the sine theta version of the identity. It equals to 1 as theta goes to 0. Now the theta is the phase that's inside the trig function. That's certainly going to 0 here. The first thing we need to do is change any non-sine cosine functions into sines and cosines. That's going to be the name of that tangent that's in the denominator. So I'm going to leave the numerator alone for now, and I'm going to rewrite the tangent as the sine of y squared minus 4 divided by the cosine of y squared minus 4. Since we have a fraction in the denominator, our next step will be to reciprocate that fraction and multiply it with the numerator. So that'll be cosine of y squared minus 4 divided by the sine of y squared minus 4. And we can multiply that by y minus 2, which you can put over a 1 for the multiplication. We multiply the numerators, we multiply the denominators. So limit is y goes to 2 of y minus 2 times the cosine of y squared minus 4 divided by 1 times the sine of y squared minus 4. At this point, we can now isolate the sine functions so that we can phase match them. That means we're going to rewrite it as limit as y goes to 2 of, and we have the sine of y squared minus 4 in the denominator, so I'll put it in its own fraction in the denominator. And we have a y minus 2 and a cosine of y squared minus 4 in the numerator. We'll put all that into another fraction. And now we phase match. We have a sine in the denominator with a phase of y squared minus 4, so we're going to put a y squared minus 4 in the numerator to phase match it to make the identity. And then to compensate, we'll put a y squared minus 4 in the denominator of the other fraction. So that first fraction is the identity. It will equal to 1 and its limit. What we need to do now is work with the other fraction, because the other fraction right now is actually still 0 over 0 because of power functions. The cosine of 0 is a 1, so we're not worried about the cosine, but because of this and because of this, if you plug in a 2, you will have a 0 over 0. What we need to do is factor and cancel, since those are power functions. So we have y squared minus 4 over the sine of y squared minus 4 times y minus 2 cosine of y squared minus 4 divided by, and then we will difference of squares factor. This will factor into a y plus 2 and a y minus 2, and it's the y minus 2 factors that are making the 0 over 0, and they can now cancel. So we've removed the 0 over 0 problem with the other fraction, and the sine fraction, even though it is 0 over 0 in determinate form from the identity, it will equal 1 because it's phase matched. So we have everything ready now to be able to work out the limit. The first term, due to its phase match perfectly, is a 1. The second term, the second fraction, does not have a 0 over 0 problem any longer, so we can plug a 2 in for all the remaining y's, and we will have 1 from the first fraction times the cosine of 2 squared minus 4 divided by 2 plus 2. 1 times anything is that same thing, so we will just cut cosine of 4, 2 squared is 4, minus 4, divided by 2 plus 2, which is 4. We will have the cosine of 4 minus 4 is a 0 over 4. The cosine of the 0 is 1, and therefore we will get 1 over 4.